So multiple choice. For this question, it's just period and range. So we know the general function of a cos graph is this one. And the period would just be 2 pi on b. So b is this part. So that's pi times 4 if you like split the fraction. So then the pi's will cancel and you just get 8. And then if you get 8, you pretty much don't even have to do the range because b is the only answer with 8 as the period. But if you do the range, it's you just have to look at this part of the function because you know it's going to start at 3 and then it's going to go 2 up and 2 down. So it's going to be 5 to 1. And yeah, also corresponds to b, so it's just b. So for this function, the things to look at are your x-intercept, the stationary points, and the overall shape of the graph. So if it looks like an M or a W, you know it's going to be a quartic graph. So it's going to be x to the power 4. So you could start with that when you look at the answers to find what type of graph it is. So you can get rid of A because that's a cubic. You can also get rid of E because that's also a cubic. So the next thing you can look at is the x-intercepts. So one of them has to be x plus 2. The other one has to be x minus 1. The other one has to be x minus 3. So looking at the answers, you can get rid of D because it doesn't have x plus 2. And the last thing to look at is the overall shape. So if it's a M, that means it's minus x to the power 4. But if it's a W, that means it's x to the power 4. So in this case, we have an M. So that means we're going to have a negative in front of the whole equation. So this one's an overall positive equation. But you can see this factor and then this equation. If you take the negative out, it becomes negative x minus 3, which means we have negative. So C is the one we're looking for because the graph is overall negative graph. So now we have a discrete random variable in binomial distribution, and we're trying to find n and p. So the two things they've given us is mean and variance. So you can kind of tell we're going to do simultaneous equations here. So we know the equation for mean in binomial distribution is NP, and the equation for variance is sigma squared equals NP 1 minus P. So you can kind of just in your CAS do 3.6, which is the mean, equals N times P. And the other one is 1.98 is N times P 1 minus P. And solve for N and P, and you should just get D. So next one, they're asking what's A intersection not B. So all you have to do is just draw a Karnaugh map. Like anytime you see like this kind of notation, it's always going to be like something related to a Karnaugh map. So just like keep that in mind when you see notation like this. Yeah, so I'll just fill it in with what we've got so far is that probability of A is 0.6 and probability of B is 0.3. But then they've also given us the probability of A union B is 0.7. We can't fill that straight into the Karnaugh map because the Karnaugh map only contains intersections. But we can get the intersection of A and B, the intersection of A and B through here because we know the formula for union is this one. So if we sub in all the things we know, so 0.7 is 0.6 plus 0.3 minus the probability of A intersection B. We can find the probability of A intersection B is just 0.2. So we can put that into here. And then we can easily get our answer because we know these two columns must add, this column must add up to 0.6. So we don't even have to worry about the rest of the Karnaugh map. It's just E. So set of 3 numbers. The easiest way to do this is, there's a couple ways. So you could just look at, so first thing to realize is that the coefficient of this first, the x with the highest factor is 1. So that means it's going to be easily factorized as something like this. If it had not been 1, it would be kind of a problem because you might have had like 2x minus c on 1 and then like I don't know, 3 or something like that. But just since there's only a factor of 1 here, it's going to mean that there's nothing else in the factorized version other than the actual factors. So one way you could go about this is just by realizing that like the 3 numbers here would replace the C, D, and E, for example. So that means, so this last factor here, not factor, sorry, this last number here, 84, would have to be just the multiplication of those 3 numbers. So you could go down and test which of the 3 add up to 84, and it's positive 84. So that means the only way to get positive 84 in this case is to have all of these be positive. So that not meaning C, D, and E have to be positive, but the multiplication of them, including the negative in front, has to be negative. You could do it that way, but it's not really a conclusive method. Like you might get more than one answer. So the easiest way I found is just to set up like equation like this in your CAS, and then just get ready to do trial and error from the bottom up by subbing in these numbers, and you should get D. Question 6 is pretty simple. Just put this equation into your CAS and solve for x in this domain. And then once you get the answers, just add them together and you should get D. Question 7, sorry. Question 7, so we have a jar and there's 6 balls and they're taken randomly and they're replaced. So they return to the jar, and we're looking at the sum of the 2 numbers. So the question they're asking us is the probability that the sum is 7, given that the first number is odd. So here I've drawn a little list of all the ways you could get a sum of 7. So you can see there's 6 ways you could get a number of 7. So a sum of 7. And the ones that are odd have a first number odd is this one, and this one. So that's important because when we expand this, we're going to have to use intersection. And then we just divide by first odd. So the probability that there's a sum of 7 and the first number in that set is odd, there's 3. And the total sample space would be out of 36. Because if you imagine like the sum of everything, it would be 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6 this way. And you just have like a giant table, but it would be 6 times 6, so it'd be 34. So the probability sum of 7 intersection first odd would be 7 on 36. But then we have to divide it by first on odd, and that would just be a half. So because like you have to include this one, this one, this one, and then every column here. And the rows. Yeah, so just going to be half. Oh, sorry, this is not 7. This is 3 because there's only 3 that are the intersection. The 7 would be the total. So it's just half. So you could do 1 on 12. 1 on 12 times 2. So that's 1 on 6. And the answer is just C. So now we have a graph of fx, and they're asking us to find what the derivative would look like. So things to note here are that when the derivative, so when the graph looks like this, so it's when it's like going from bottom left to top right, that means the ddx is positive. So the graph of fx would have to be positive. So it would have to be over the y-axis. So y have to be, because y is f dash x, it would have to be greater than 0. And if the graph is going from top left corner to bottom right, that means ddx is negative. So then that means the graph has to be below the graph of fx has to be below the x-axis. And the other thing to note is that when there's like a vertical line, that means g dx is undefined. So that's kind of related to when you have, like, it might be caused by a fraction with a 0 underneath it. And the other thing, it's not really relevant to this question, but just like we already know, stationary points. So when the graph is flat is when d dx is 0. So that might be caused by a 0 at the top, or a fraction, or just 0 in general. So we can see we kind of have a vertical line here. So that's going to correspond to this. So we're looking for something that's going to be undefined at this point. So if we look at the graphs, undefined in this case would mean an asymptote. So it doesn't particularly help us because all of the graphs have asymptotes in this case at x equals 1, but we can look at the rest of the graph. So we can see it's going down here and it's also going down here. So as I said before, because it's negative, that means the whole graph is going to be under the x-axis. So just by that knowledge, we can easily get rid of all the answers except for E, because it's the only one where the graph is underneath the x-axis for all values of x, which is what we can see here because the gradient's always negative, except for at this point where it's undefined. So next question is question 9. So we have a continuous random variable x. Sorry, I didn't highlight that. We have mean and standard deviation, and it's just asking, so what's this equal to? So they've given us this one. It's z between -2 and 1, but more often than not, they actually this one's the one that will lead you to the answer. So you just have to look at the symmetry properties of the standard normal distribution and realize the area between -2 and 1. Oh, sorry, this is a -1. Is the same as the area between -1 and 2. -1 and 2. So to find the interval of x, we would just use the rearranged version of this equation, so this one. So if we start with this one, say, you probably don't want to start with the one they gave you because, like, more likely it's going to be this one. But I think in this case, it might have been this one. I'll just try it. So the first one you're going to convert as -2 and then 1. So x is sigma is 5, -2 plus 40. So x is 30. X is 30. So this is when z is -2. And when z is 1, x is 1, 5 plus 40, so x is 45. Yeah, so it didn't work. So as you can see, none of the options are probability of 30 to x to 45. So if we look at this one, so that's saying the probability x is greater than 30 minus the probability that x is less than 45. So say this is 30. Oh, yeah, this is 45 because they're all 1 standard deviation away from the mean, which is 40. So it's saying this area minus this area. So you can see that's clearly not going to get you this area, because all you're going to get is this area, but you're also going to get a negative version of this area, which means you're literally minusing the same amount of area, so that's going to be 0. So it's not going to be E, even though you got the same numbers. So just because you get the same numbers, don't immediately choose that one. So as I said before, it's more likely going to be the symmetry property one that has the answer. So we'll do the same thing with the z values. So when z is -1, x is -1 times 5 plus 40, so x is 35. And when z is 2, x is 2 times 5, sorry, plus 40, so x is 50. So now we're looking for probability x is between 35 and 50. And we do have an answer for that one, and that's B. So yeah, so for these types of questions, like always look at the symmetry properties first. Don't even bother with this equation because it's probably not going to help you, but just try to find two z values, which will give you the same area. And those two z values will literally like always be just the negatives. So it's going to be -1 and it's going to be negative of -2. So it's going to be +2. So yeah, you just have to multiply both of them by -1 and swap the terminals because one will be, the one that was positive would be lower than the one that wasn't. Yeah, but be careful if both of these are not, like if the both of them are positive or negative, like if you have it here, but it would be the same anyway, but just like, you know, they probably wouldn't give you that. They usually have one negative. So the range of this function, just graph it. Do not use the stationary points because you never know if the stationary points will correspond to an actual minimum. So like it might go like, I don't know, like this. Nope, that's not like this. So if you calculate the minimum and the maximum, you'll get this range, but the actual range might just actually be all real numbers. So just graph it and be careful of the endpoints, like this one's not included. But in this case, it doesn't matter because neither of the, this endpoint wasn't actually the minimum or the maximum. So that's another reason to graph it. So the maximum domain of the function gx is what? So we know with log functions, oh no. So we know with log functions, the inner part always has to be greater than 0. So the inner part in this case is -2x. So if you think about it like the graph of -2x, and we want this graph to always be greater than 0, so it can't be equal to 0. So that means, oh no. So at this point, we can't include that point, and we want this part of the graph. So you can see easily from this diagram that the x values you need are from -infinity to 0, but you can't include 0 because all you need is for this graph to be greater than 0. So this is your range, domain, sorry. And that's going to be the negative reals. Just with this notation, all it's saying is that it's negative reals, but they don't include zeros. That's why that's what the signs mean. So question 12, average value. So you can just plug these stuff into this equation and solve for A. You should get D. If your CAS is not working, after you put the integral sign, so dx, after you get dx, so on your CAS, like you have a small cursor. If you click to the right, you'll get a bigger cursor. That's where you want to put the solve thing. That's when you want to put comma, oops. So you get a small cursor, and then you'll click once to the right and you get a bigger cursor, and that's when you do comma A. If you don't do comma A, if you don't do if you don't get the bigger cursor and you're still typing in a smaller cursor, the solve function won't work because it's still associating that with the integrals. So if you're having issues with your CAS where it won't solve, anytime you're trying to solve for something, before you put the comma for whichever letter you want to solve, make sure you always have a bigger cursor. So question 13. So it's gonna gives you a property and just which function is it. So easiest way to do this question is just to use the judge function on your calculator. It can be found in the catalog. Just scroll down to J, or you could save it as a shortcut because at least one of these questions comes up in every multiple choice section. So it's probably easier to just save it as a shortcut key. A possible rule, if you don't have the judge function, unfortunately, you're going to have to do it all by hand. Yeah, but it should be fine, hopefully. But yeah, you just get D. So question 14, we have a bunch of translations. So this is the original rule. So first translation we have is dilation from the x-axis by a factor of half. So it's from the x-axis, that means it's going to affect y. So it's half y, and then reflection in the y-axis, that means it's affecting x. And then the translation of pi on 6 in the negative x direction. So negative pi on 6, half y. And a translation of 4 in negative y direction. So, and half y minus 4 in that order. And we're trying to figure out what the transformed rule is. So with this, we know these are going to be x dash and y dash. So just write our equations. X dash is negative x minus pi on 6. So x is negative pi on 6 minus x dash. So that's 1. The other one is y dash is half y minus 4. So y is 2y dash plus 8. So we have our original equation, y is 3 cos x minus pi on 6. And you can just sub x and y. So 2y dash plus 8 is 3 cos negative pi on 6 minus x dash minus pi on 6. So y dash is 3 on 2 cos negative x dash minus, it'd be 2 pi on 6, so it'd be pi on 3, minus 4. So now we just, so the thing is, so it might ask it in a different form, but first we can check this form. And there is an answer for this form, it's A. But they might not have shown us this form. Sorry, they might have drink some water. They might have taken out the negative because cos is a positive function. But in this case, we're lucky because they've just given us this the raw equation, I guess. So for this question, it's asking you to use the additive properties of integrals. So we know a to b fx dx plus b to c fx dx is the same as a to c fx dx. So in this case, if we replace this with, so we're trying to find 3 to negative 3. So 3 to negative 3. So to do that, we're going to need 3 here and negative 3 here. And the number in between would be 2. So 2 to negative 3 is negative 8. They've given that here. And 3 to 2 is 10. So 8 minus 10, 10 minus 8 is 2. So the answer is 8. So for this question, it's a function in a function. So for these questions, you always want to draw a domain versus range graph for each of the functions. So the function that's in the function is gx. So that means we're going to have to match these two boxes. So we'll just start with fx. So the domain of fx would be 0 to infinity. So it'd be positive reals. And the domain of gx is all reals. And the range, so the range of this is just, so it's like a parabola. It's just going from 1 to infinity. So it's 1 to infinity. And you can see 1 to infinity is already a subset of the reals, the positive reals, because it's a, so the domain of fx is this one. And the range of gx is this one. So this is already fitting in with that range of values. So we don't have to do anything to the domain of gx. And that already tells you that your domain is going to be the reals. So you can get rid of c and d. And next thing to deal with is the range. But with the range, we know that the only values that can go into this fx function are 1 to infinity. So you no longer have 0 to infinity going into negative ln x. So if we draw the graph of negative ln x, looks something like, wait, positive ln looks like this. So yeah, it should look like something like that. And this would be 1, 0. So if we're going from 1 to infinity, we're going from here to infinity. So we're going to look at this part of the graph. And the 1 is inclusive, so include that part, but the range would be negative infinity to 1. So just looking here, it doesn't look like it's an answer, but negative infinity, oh, sorry, not negative infinity to 1, negative infinity to 0, because that's the range. So the negative reals would be negative infinity to 0, and then the union part would include a 0, so that's why that's E. So question 17, to do this, you just have to know that the little fx is the derivative of the big fx. That's what the capital means. This is kind of a trick question because there's a rule for this in special, but you can figure it out. So we know that, so we start with this one. So fx is the integration of fx dx, but we don't want that. So what we do is, so we want the integration of 8 to 4 fx dx, and we know that's going to equal, so using this property, we know that's going to equal f of 8 minus f of 4. So if we just rearrange this, it's very simple. You just move this to the other side. F of 8 is f of 4 plus 8 to 4 f of x dx. And coincidentally, not really, because it's the point of the question, they've given you what f of 4 is. So f of 8 is just, replace this with negative 6, and it's going to be E. So yeah, just be careful of what the capitals mean. Question 18, this question is kind of a bit mean because they expect you to look very, very closely at the graph. So if we do our usual transformations, you'll find that we actually get 2 answers. So like, for example, if you test the asymptotes, these ones, like with the transformation graph using x dash and y dash, you get 2 answers. Both C and D will work. So you'll have a hard time figuring out which one is correct. But the trick with this question is, if you looked carefully at the graph, you'll see you'll see, well, first that they said both of them have the same scale, and then you'll see that there's a slight dilation here that you're supposed to pick up. So looking at the dilation, you're supposed to get rid of your answer C and choose D instead because it's the only one with dilations. Yeah, this question can be a bit mean because if you did it just by hand, you'd only get one answer. So you might just choose C, the first one you got. The first one, like, because you're going down the list, you're in a hurry, you get this as answer, it works, so you choose C, but C would be wrong because they expect you to look at the graph and there's a slight dilation. So with the dilation, you're supposed to get rid of all 3 of these answers and just look at D and E. But yeah, that's a bit harsh because you probably wouldn't have been paying attention to that. Question 19. So this is sampling. The trick here is not to look at this. This is the population. This is not the sample size. This is the sample size. So don't just use the largest number as a sample size. Read the question properly. This is also important information because you can kind of tell it's going to help at the end to choose which answer is right, because it's yeah, like you should get that kind of feeling. So standard deviation is 0.3, 0.03, and it's asking for the number of blue marbles. So the proportion is just how many blue marbles there are in the whole box. So it's going to be number of blue marbles over 100 marbles. So the standard deviation in sampling is P1 minus P over N, and standard deviation is 0.03, and N is 100. So we have this equation, and you can just put that into your CAS to solve it. And I'm pretty sure you get two answers. You get 9 on 10 and 1 on 10. And that's when this phrase comes in handy, because blue marbles is going to be greater than red marbles. So if we know the box has to be either red or blue, that means the probability of red is going to be probability 1 minus probability of blue. So that means blue has to be this one, because otherwise, if blue was this one, the red would be greater than that. So, oh, sorry, it's not what it's asking. So now that we figured out the proportion, that's why this comes in handy. So 9 on 10 is the number of blue over the sample size, 100. But okay, so now we've transitioned from the sample to the actual box. So now we just have to multiply this to 2000. So number of blue would be 220,000 times 9 on 10. So it's just going to be 18,000. So now it's D. So yeah, just this question is kind of weird because they've used the proportion. I mean, it's not weird, but they've used the proportion from the sample and generalized it to the whole population. So just like know what's happening with N, and that's it. So question 20 can be a bit hard to visualize. So the equations in the solution, but solutions by VCAR, they use this formula set here. So they got f dash x times f dash y is 1, which is kind of the same as saying this. So that's how they got that one. So then they said f dash y is 1 on fx, but I find that I don't really understand what they're like trying to do here, because they just randomly popped out with gx is f dash y. So I think it's easier to draw a graph. So the points we have, this is 3 on 7 at 3 on 7, and at 7 it's going to be 8. So just pretend that's at 8, and at f dash 3 it's 2, so it's a bit like this, and f dash 7 is 3, so it's like this. Oops, just 8. So the function is differentiable, so g is the inverse of fx. So for here, g of 7, so we know that so f and x are interconnected by this f inverse x, this relationship. So at x, fx is going to be y, and at y, f inverse x is going to be x. So if we're looking at g dash 7, that's the point. So since we've only been given f values, we're going to look at something that's has a y value of 7, because the x value of gx would be 7. So when we're looking at fx, the y value is going to be 7. So the point that gives you something 7 is 3 and 7. So this point here. So if we imagine, I don't know, a graph looks like this, and this is the inverse, so fx, I mean, it has a point here, but let's just pretend it looks like this. F inverse x. So this is going to be the most relevant point here. So the corresponding point for us would be this one. So we can tell it's still going to be positive, but now we have to figure out what g dash 7 is. So we take f dash 3, so that's going to be 2. And you don't take b, because that would be f dash 3. but you take 1 on 2 because you could tell, just graph it and you can kind of tell it's still going to be positive, but it's not going to be anything steeper or less than. And Vika's also given you the formula that g dash x is equal to f dash of y. So that means if f dash of y is 1 on f dash of x, so then gx is 1 on f dash of x. And as I said before, f dash x is 2 because x in this case is 3. Actually, I think this formula is a bit misleading. I will just replace x with y because it's going to be that point xy. So that's going to be 1 on 2. So that's why it's A. So that's multiple choice. So somehow I transition to purple. Okay. So this question is just CAS question. So just put this into your CAS and use the transform function. Menu, and then go to factorize and just do that. Sometimes the CAS might be funny, it might not work. Just use R factorize, that usually helps. But you should get fx is x minus 2, x cubed plus 2x squared plus 4x plus 4. So you can easily see by comparison that A is 2, B is 4, and C is 4. Make sure you always answer the question, like don't just put this form and not state what A, B, and C are. So for 2 consecutive integers, solution to fx equals 0 is in the interval m and n. So like the thing to kind of realize with this is that if it's in the interval of 2 integers, that means we're looking for a decimal because the interval is non-inclusive and it's going to be between it. So we're looking for a decimal answer. So all you have to do is solve fx equals 0 in your CAS, and you get negative 1 point something. Don't remember what it is. But if it's negative 1 point something, then the 2 integers it's going to be between is going to be negative 1 and negative 2. So if we look at the sort of like domain for those 2 values, m is going to be less than n. So that's m is negative 2 and n is negative 1. And this domain also kind of supports your answer because you got a negative decimal and m and n are negative, so that makes sense. So equation of the line through 0, negative 8, 2, and 0. So just use that equation, y minus y1 is m x minus x1, and you should get y equals 4x minus 8. So set the equation of the lines through P and Q. So in this question, there's a straight line. This is a straight line. And there's another straight line that's parallel to the horizontal axis that touches the point at Q. So that means this is also a straight line. So if it's asking for the point, the equation of the line through P and Q, and it's a straight line, that means it's a horizontal straight line. So it's just going to be y equals a value. And to find the value, we need to find either point P or point Q. The easiest one would be to find point Q because it's already on our we already have an equation for it. So using the previous equation, that one, just solve f dash x equals 0 because as you can see, this is a turning point, and choose the one that has an x value between 0 and 2 because as you can see, Q is going to be less than 2, or just straight up find the minimum. And that would be your x value, and you should get negative 11. So state the coordinates of P and Q. So Q you already have because you would have figured it out while trying to find this answer. So Q is 1 and negative 11. But you also know P is the point at which these 2 lines intersect. So you can just solve 4x minus 8 equals negative 11. And you should get x is negative 3 and 4. So you have your x value, and P is on the line y equals 11, so you don't have to solve for your y value because you already know what it is. So P is -3 on 4 minus 11. And always make sure to answer the question again. So state the coordinates, don't just put the X values. Yeah. So there's a new transformation and it's applied to the graph of F. So P is the image of Q. So that means that if P is the image of Q, P is the old one, the new one, and Q is the old one. So P is the one that's been transformed. So for this question, just do your normal transformation expansion. So X dash is X plus D, and Y dash is just Y. So you could kind of just ignore Y dash, especially given that it makes sense because both the X and Y values, both the Y values are the same. So the old X is going to be Q, and the new X is going to be P. So -3 on 4 is 1 plus D. I'm getting these values from here, just the X values of the coordinates. So D is -7 on 4, and that's it. So now we're looking at the points M and N. So if we go back to our first question, M and N are -1 and -2. Oh, I went too far. So again, using this equation, but this time we know D, so X dash is X minus 7 on 4. 7 on 4, so our original X was -2, so M is -2. Maybe I'll write X is M is -2 and X dash is M dash. So M dash is -2 minus 7 on 4, which is -15 on 4. And so same thing for the N value. So sub X is N is -1 and X dash is N dash. So N dash is -1 minus 7 on 4. So N dash is -11 on 4. So probability question number 2. So the first question is, what's the probability that 2 defective? So you could just put this into your CAS, and you should get 0.0498. The p-value here is given 0.08, and n value is given here, so it's 5. And yeah. So now it's asking probability 2 defective. Given that at most 2 are defective, so that means 2 or less defective, including 2. So just remember with discrete probability, always be careful of what's included and what's not. So it's going to be, so the intersection of 2 or 2 or less is just going to be 2. So probability 2 defective over probability 2 or less is defective. So we figured out in the previous question our numerator, but you can just put both of these into your CAS. You should get 0.0501. So now we've gone to sampling, and it's asking for a 90% confidence interval this time. So you could either use your CAS function, that's in statistics. Just go to intervals and go from there. That's probably easier because then you don't have to figure things out. But this question is 2 marks, so you might want to write your equation. And this time it's a 90% confidence interval. So if you ever don't remember what the values for the different intervals are, just go to inverse norm in your calculator and let the probability equal 0.9. And in if you have the white CAS, choose center. If you have the black CAS, I think your guys' setting is set to left. So if you figure, if you want a 90% confidence interval and you want A and B and you only want either B or A, preferably A, so you're going to do 0.5 plus 0.45. So if you have the black CAS, so your probability is going to be 0.95, and your tail settings set to left. But yeah, so just put 0.95 and you should get the value. The value is for 90%, it's approximately 1.64. So our confidence interval equation is this one. That's sigma, so p hat plus 1.64 times sigma. And p hat in this equation is 0.08. And sigma is square root p1 minus p on n, and n is 50. So just chuck that all into your cas, and you should get 0.0169 to 0.1431. So now we're going to normal distribution, and it's asking for what's the probability that, I'll just define x. So let x equal depth. So what's probability that the depth is greater than 20.6? This is just a cas question, so just put that into your cas. And this is mean and standard deviation of these ones. And you get 0.0228. So depth of hole must be within 0.5 of the mean, otherwise mode is defective. So the mean is 20 millimeters. So if it's inside if it's not defective, if it's not defective, that means it's within, it's between 19.5 and 20.5. So if it's going to be defective, that means it's going to be 1 minus the probability that it meets this criteria. So 19.5 x 20.5. And again, it's just a cas question. You should get 0.0956. You could also do this as the other interval. So probability that it's between 0 and 19.5 plus probability that's between 20.5 and infinity. But that would probably take longer, so just use this one. So now we have a mixture of both of them, and what's the probability that it contains exactly 2 defective components? So there's there's 3 ways you could have 2 defective components. So you could have one of each that's broken. So I'll just use the dashes to mean that they're defective. So you could have 1 defective sensor and 1 defective motor, or you could have 2 defective sensors and no defective motors, or you could have no defective sensors and 2 defective motors. So for this, we've transitioned into like binomial distribution again, but it's kind of a bit weird. So this is going to be like intersection. So it's going to be not actually plus, it's intersection. So all you have to do to find like the value of one of these is just get the probability. So since they're independent, get the probability that one sensor is defective. So I think we figured that in, they already gave us to us, so that's going to be 0.08. And the probability that one motor is defective, so I think we figured that out here. So this value times 0.0956, and just find that whole value. I think I got approximately 0.09162, and then this one was 0.03157, and this one was 0.004454 ish. So for the ones that are not defective at all, you would multiply it by the probability that it's not defective squared. That's it. So, and then just add everything together and you get 1.66. Just be careful with the decimals in this question because everything else asks for 4, but now they've asked for 3, and you don't want to lose mark just because you wrote the wrong decimal points. So now we have a knob that's, we're talking about knobs, and so the defective So the way a knob can be defective is if it's has a height greater than 30 or less than 29.6. So as we want the amount of knobs that are defective to be less than 2%. So we want the probability that the height is less than 29.6 or that the height is greater than 30.4. We want that to be less than 0.02. So this is the probability that it's defective. So the thing to realize with this question is that, so if we draw our normal distribution curve with a mean of 30, so it's like approximately looks like this. So 29.6 is here and 30.4 is here. So the probability that h is less than 29.4 is actually the same as the probability that something is greater than height, that the height is greater than 30.4. So these two probability values are the same. So you can choose whichever one you want to get rid of. I chose to write it as 2 times the probability h is less than 29.6 is less than 0.02. But it doesn't really matter which one you choose. Then you can just take the 2 and divide it. So 29.6 is less than 0.01. And then from here, there's a couple ways you can go about it. You could go into statistics and put in, not statistics. So you can put in to your CAS just the way you would normally do it. So use norm CDF and then do 0 to 29.6 and sigma, just leave it as x, and mu put in 30 because that's 30. And then when you press enter in main, it won't work. It'll give you an error. But then just copy and paste this whole function and then go to your graphs menu and then paste it into one of those y equals things. So y equals this thing. And then you'll see this little button at the top that looks like this. That means tables, and then look at tables. And so for this question might be it might not work this way because sigma is 0.17, and usually the default setting for this is like whole numbers, so it might not work, but you can change the like domain and step size. The only problem is like you wouldn't know beforehand that this was a decimal, so you probably wouldn't need to you wouldn't know to change stuff. But if it wasn't asking for sigma, if you knew that and it was asking for mean or something, you could easily do it like that. That's generally what we use for binomial distribution, but for normal CDF, it might be harder. So the way to go about this question is to use standard normal distribution. So 0.01, so just find the value of z for which the same probability occurs. I got negative 2.3263. And then just use your formula. So negative 2.32 is 29.6 minus 30 on sigma. And you get sigma is 0.17 to 2 decimal places. So continuation of probability question, but now they've given you a density function. So the mean weight, so EW is just integration W CW, from 330 to 290. That gives you, I think it may have been exactly 306. So determine the probability that something randomly selected weighs less than the mean. Don't get tricked by weighs less than the mean into thinking it's 0.5. That only applies to normal distribution. This is not normal distribution because you have a graph. So this is not equal to 0.05. So to find this, so probability W is less than 306 is 306 to 290 CW DW. You should get approximately 0.5248. Question 3. So we have 2 sine functions. and asking for the total area. So first just realize that this one's on top because of the C value where it starts from. And this doesn't really affect it much, but yep. And to find area, just do, so the other thing that they've given us is its length of 80 and height of 20. So it's length of 80 here and height of 20 here. So to find the total area, just do 80 to 0. The top function, so y1 minus y2 dx. For this question, it's not really important which one's on top, because even if you got a negative area, you'd realize which one's on top. But it's always good to like figure out the context of the question, and it might be relevant later on. So now we have vertical height, and what's the minimum. So for this question, if it's 3 marks, you might want to define a function of d, so y1 minus y2. And if you expand and simplify, I got this value, this function, and d min in your cas, and remember to put the domain, so x is from 0 to 80. The d min is 514 meters, and it's asking also when x this happens, and that happens when x is 5 pi and x is 25 pi. So average value we know is just the same equation we used in multiple choice, dx dx, so that's like 4.46 meters. So now we have the boundary curves, but they've replaced part of it with a polynomial. So find values of the maximum value of p for which the curves don't intersect. So p is a range of a values. So what they're asking is what's the maximum value of a for which the curves don't intersect. So if they're going to intersect, we usually equate them. So we'll start like that. So a sine x on 10 plus 15 equals a squared sine x on 10 plus 10. So if you bring the constants to the left and you factorize out sine x on 10, no, sorry, you might want to take out the a's, so a squared minus a sine x on 10. So all I've done here is just brought the constants here and factorized out sine after putting it to the right. So sine x on 10 equals 5 a squared minus a. So if it's not going to intersect, that means this won't have any solutions. So the way to not get any solutions is to make this value out of the range of sine x on 10. So the range of sine x on 10 would be 1 to -1. So essentially what we're doing is we're getting 5a squared minus 1 to be either greater than 1 or 5a squared minus a to be less than -1. So if we take 1, oops, so it's 1 or 2. So if we take 1, 5 is going to be, if we cross multiply, 5 is going to be greater than a squared minus a. And if you just do your, so a squared minus a minus 5 is less than 0. So if you use quadratic formula and realize that it's a positive, so if it's less than 0, you're going to want the intersection between the answers. It's going to be 1 minus root 21 on 2 to 1 plus root 21 on 2. And the second thing is this one. So 5 is less than a minus a squared. So a squared minus a plus 5 is less than 0. So this one, if you test the discriminant, it's less than 0. So that means for all values of x, there's like no solutions. Yep, so the second part, this one becomes irrelevant. So now we just have this here. So 1 minus root 21 on 2, 1 plus root 21 on 2. But a is a member of the positive rules. So that means a cannot be less than 0. And if you look at here, so root 21 is like definitely going to be greater than 1. So this numerator for this fraction is going to be less than 0. So that means we can just replace it with 0 since that's the maximum value it can be, and that's a subset of the original function. And you can see we kind of have a range of a values now, so p is just 1 plus root 21 on 2. So find the value of a for which the shaded area is a maximum. So to do this, I just wrote ax is integration 80 to 0. So to figure out which one is top, again, I used the constant values. So c1x minus c2x dx. And then in your cas, don't like equate it or anything, just put this straight up in there. And then you'll get a function of a, because it will expand this, cos 8 minus 10a squared, cos 8 plus 10a plus 400. So now you have a function of the area in terms of a, and you can easily find a max, which is 402.68 meters squared when a is half. So last question, question 4. So we start off with a function x minus x ln x, and so find the values for which f dash x is between -1 and -half. So for these two questions, it's just a CAS question, but for 2 marks for this one, you might want to define what f dash x is. So f dash x is 1, what's the question? F dash x is 1 minus, so if we differentiate x, it's nothing, so ln x, and then plus -1, so it's just going to be ln x, or you could just put it into your cas. And then the range of values, so also put that into your cas, and make sure the interval is not inclusive, so it's going to be root e to e. And just once you've got your answer, just look at the graph to confirm that it makes sense. So we're looking for when the gradient's like negative, so it makes sense that the range of values is after 1. So same thing here, just put it to cas, you get 1 on e to 1 on root e. And if you test these values, they'll be less than 1. And again, that makes sense because the only time the graph is positive is like between these two range of values. So this question is really important because it generalizes this, things you'll need for the rest of them. So it's only worth 1 mark, but it's quite important. So find the equation of a tangent at a point A. So just on your cas, use tan line in your calc menu, and you should get y equals ln ax plus a. So the significance of this is that now you can put in any point and you have a tangent. So this is like a generalized solution for all the tangents of the function fx. And that's important here because now you can figure out what the tangent at 1 on a is, because you can just put 1 on a into a. So you get y equals negative ln a times 1 on a, sorry, x plus 1 on a. So just replace every instance of a with 1 on a. So you can even take out the negative, so ln a x plus 1 on a. So that's your tangent at x equals 1 on a. And tangent at a is just what we found here, so minus ln ax plus a. So if we're finding points of intersection, just equate the y's. So ln ax plus 1 on a is negative ln ax plus a. So 2 ln ax equals a minus 1 on a. Oh, sorry, that's not how that works. ln ax plus ln ax equals a minus 1 on a. So if you take out the x, no, yeah, that's fine. But I'll choose to, so once you get here, you get to ln ax, but I'll choose to absorb the 2 into the inside of the function to get a squared, a minus 1 on a. And so x is, so ax ln a squared is a squared minus 1 on a. So that means, yeah, so then x is a squared minus 1, a ln a squared. And so you don't want to do that by hand again. I probably should have done most of this by CAS. But you can put that back into your function to get y, and this is your coordinates. But make sure to write them in coordinate form and not what I've done here, because it's asking for coordinates. So hence find the coordinates of the point of intersection of tangents to this. So the trick here is that that's why doing this was so important, because now you can replace a not with 1 on a, but you can replace it with e and 1 on e. So just get your answer to the previous question. So it was a squared minus 1, a ln a squared, and then a squared plus 1, 2a. And then just replace everything by e. So let e equal a. So then you get e squared minus 1, e ln e squared, and then e squared plus 1, 2e. And just with here, we know we can take out some stuff and simplify it. So we get 2e, e squared plus 1 on 2e, which is a very neat answer. So now we have value of b, which is greater than e, and tangent to f at that point, and at 2 intersect the x-axis at the same point. So first, the question sounds complicated, but we'll just start by finding what the tangents are. So the tangent at b, again, this is why this is so important, because we're going to use that again here by subbing a is b, so ln b x plus b, and tangent at 2 is y equals negative ln 2x plus 2. So since they're going to have the intersect the x-axis at the same point, they're going to have the same x value. So I'll just rearrange these to find them in terms of x. So y minus b on negative ln b, and this is y minus 2 on negative ln 2. And then since the x values will be the same, we can equate these two things. So y minus b ln negative ln b, is y minus 2 negative ln 2. So the assumption we've made here by equating them is that they're equal at the point when they're on the x-axis, because that's when the x values will be the same. So with that same knowledge, if they're on the x-axis, then the y value for both of them will be 0. So you can take out the y's. So negative b on negative ln b is negative 2 on negative ln 2. And you don't even have to solve for it. You can clearly see that b is 2. However, there's an issue with this. So b is 2. This does not fit in our domain. B cannot be 2 because b is greater than e. So then you might start to panic because you don't have an answer. But the trick here is just put this into your CAS and you'll actually get an answer of b is 4, which makes sense because negative ln 4 is negative ln 2 squared. So be negative 2 ln 2, and then the 4 on top will cancel and you'll get the same thing. But yeah, if you put this into your CAS, you'll get a second solution, and this does meet the requirements. It is greater than e, so b is 4. So this is a show that question. Again, very important that we have this because we're going to use it once more. But this time we have a tangent at p and q. So tangent at p is y minus ln p. No, sorry, y equals minus ln p x plus p, and the tangent at q is y equals negative ln qx plus q. So again, just do the same thing, get them in terms of x, because again, they're intersecting on the x-axis. So x equals p minus y on ln p, x equals q minus y on ln q, and then let them equal each other. And at the same time, I'll just, for simplicity's sake, I'll let y equal 0 equals q ln q. And now we are really close to the answer. If we cross multiply and get p on q on one side and ln p and ln q on the other side. So from here, we're going to use that rule that's like log EP on log EQ is log PQ. So P on Q is log PQ. So if it's log PQ, that means P to the power P on Q. Oh, I done this wrong. Oh, sorry. This should be Q on P. Q on log ln P ln Q on ln P. So this is in fact the other way around. Q of P. So this is log Q of P. Sorry. So that means so this is a Q. So Q to the power P on Q is equal to P. So that's just interpreting this one. And then you can multiply, but not multiply. So put both of these to the power Q, P to the power Q, 1 times Q. And then the Q's in this case will cancel and just become 1. So Q to the P equals P to the Q. And you have the answer. Oops. So find the equation to the tangent at x equals square root of e. You can use the same equation as before, but this one you might want to do it again because it simplifies, and your CAS will simplify it for you. So find the coordinates of E and F. So E is the x-intercept at the tangent. And so it's the x-intercept of this one. So just let y equals 0 to find this. And F is the point at which the tangent equals 1, as it says here. So just let y equals 1 and find x values for both of them. It's just 2 marks, so you might just have to put the answers. But if you want to put working out, you can write something like this. So let y equals 1. Then x equals 2 root e minus 2. So that means make sure it's asking for coordinates. So always write the y values, but for both of these, you don't have to figure out what the y values are because e is an x-intercept, so the y value is 0, and f is when the y value is 1, so it's already given to you. Let's find the area of the quadrilateral EFGH. So we know EH and GF are straight lines, so we have a trapezium here. So you can use the area for a trapezium. So GF plus HE divided by 2 times GA. And then just like visually look at what the points are. So maybe I'll just write what I wrote. So let GF is 2 root e minus 3 and HE is 2 root e minus 1 and GH is 1. So that means area is 2 root e minus 2. Oh, sorry. And just write units. So find the area of triangle QGH. So luckily it's just a right angle triangle. So that means we can use area equals half base height with no issues. Base is QH, so e to 1, so e minus 1. And h is GH, which we found in the previous question was 1. So area is just e minus 1 on 2 units squared. So find an approximation by calculating the average of the areas we just found. So for calculating an average, we just add both the areas together. So 2 root e minus 2 plus e minus 1 on 2, and just divide by 2 because that's how you find the average. And that simplifies to e on 4 minus 5 on 4 plus root e units squared. That's all you have to do for that question, so then 1 mark. So now you have to find the approximation, the error of approximation, obtaining part E as a percentage of the actual area. So this requires you to find the actual area. So if we look back at the graph, the actual area is going to be the area under the graph from E to A. So actual area is e to 1 fx dx, which comes out to e squared minus 3 on 4. So the percentage error is going to be the actual area minus the approximation, so e on 4, e minus 5 on 4, plus root e, and then divided by the actual area. And then because we want it as a percentage, just times by 100, and you should get 1.73. And yep, that's everything.